So I want to just take a quick moment to thank everybody for coming down today. Definitely appreciate you being here. For those of you who don't know me, my name's Mark. I'm one of the administrators for the Nova GMRS group on Facebook. And we have a team of 3 other administrators that I work with to help keep the Facebook group running, get events put together, things of that nature. I've been messing around with radio since, I guess the mid-70s. And I'm an amateur radio operator as well as a GMRS operator. And part of the reason why I wanted to put this presentation together today is because our community is starting to grow quite a bit as far as GMRS operations are concerned, new owners coming on board. And there's a lot to kind of ingest in a short period of time. And I've seen people making mistakes in purchases and not quite understanding some of the fundamentals of the technology and how things worked. So my goal is to help get people to understand just some of the really basic fundamentals here today. It's legitimately an intro class. And hopefully when everything is said and done, you'll have a good understanding of how the radio technology works overall, not necessarily any one specific radio. You get a little bit of exposure to antenna technology, which is also a very important part of how this works. And as we start to close out the class, we'll look at some of the programming software that's out there and talk about some of the different things that you'll do when it's actually time to program some of these radios. And then we'll just do a quick glimpse at the FCC website and the things that you need to do to actually register to get a license if you don't already have one. Definitely want to thank OCD Offroad for having us out here today. As I mentioned earlier, the off-road community is really getting away from CB radio and starting to move toward GMRS, and OCD is a part of that. They're a Midland dealer here, and they opened up the shop to us to do today's presentation. Definitely want to thank our friend Mike Washwell in the back. Mike is one of the repeater owners. He probably owns most of the repeaters in the Maryland, DC, and Northern Virginia area. And he's going to be here to help answer some questions after the presentation. So, there's quite a few of us here that are knowledgeable about the radio. So you can ask myself, Mike, and Ron's here also. Any one of us will be happy to answer questions as we wrap up. So let's see. So GMRS, why was GMRS created? It's actually part of the personal radio service. It's a short-range, low-power radio service that's designed to facilitate the needs of an individual and their family. It's not intended to be a long-range communication service by any means. It's in the same family as CB radio, family radio service, which you're familiar with, I'm sure, FRS, and also the multi-use radio service, commonly known as MRS. Let's see. All right, so General Mobile Radio Service is a licensed radio service that uses channels and part of the radio spectrum known for providing better audio quality, especially compared to other technology like CB radio. The reason for that is because we actually are able to use more radio space, and we're able to put more information into the transmissions that we make, so you're able to get better fidelity out of it. Again, most common use is going to be short distance communications. Often it's less than a couple of miles. Sometimes it's only a few hundred yards, depending on what you're doing. One license can be shared with your entire immediate family, mom, dad, brother, sister, children, grandparents, all covered under one license. And it's not restricted to a single radio. You can have as many radios as you want under that license as well. And something that's commonly overlooked is the fact that going back to 2017, the FCC had some rule changes that they put in place, and with the new rule changes, you can now put data over the air as well. And we'll touch base a little bit on what we can do with that as we move forward. GMRS uses the exact same channels as FRS does. So if you already have an FRS radio, or if you have friends or family who already have an FRS radio, you can talk to them no problem. There's perfect overlap from 1 to 22. Let's see. Okay, so talking about compatibility with FRS, we got just a few bullet points here to talk about, just so you can see what some of the common differences are. I've actually had people ask me, well, you know, if they're using the same channels, you know, why should I bother getting a GMRS license? So, you know, as we mentioned, there is a license requirement. It's $35 for 10 years. You're talking about a little bit less than 1 cent a day, which is a pretty good deal as far as I'm concerned. Now, I put that there's no license needed for FRS, but it's still a licensed service. It's what they refer to as license by rule. There are rules that you have to follow with FRS. And by the mere act of using the radio, you agree to obey the rules, and then you are considered in compliance with your license. It is possible to be in non-compliance with the rules and then potentially get fined if you are doing something that you shouldn't be. Another difference is going to be station identification. GMRS, you're going to have to identify yourself every 15 minutes, and you also need to identify yourself at the end of the conversation. FRS doesn't have any need for station ID, none's issued. So if you're on your GMRS radio and you're talking to someone on FRS, you still need to identify even though they are not. And the reason for that is because of the technology. You're licensing your station. If you're using an FRS radio and you're talking to another FRS radio, or if you're talking to a GMRS radio, you do not need to use your GMRS license, because at that point you're going to be using an FRS compliant radio, and that's where the license by rule applies. Let's see. So in GMRS you can get mobile radios as well as in handhelds, but in FRS there are only handheld radios. There are no mobiles. Transmit power in GMRS, depending on the channel you're on, you can actually go up to 50 watts of transmit power. That can help quite a bit if you're in an area where maybe distance is becoming an issue, or maybe there's obstructions in the way that would normally impact your signal. If you're only using a few watts, you can boost your power up and be heard a little bit better. Another benefit to GMRS compared to FRS is you can actually buy some high performance antennas that can really make a difference on how well your radio operates. With FRS, your handheld radio has a fixed antenna. It's not removable. You are not allowed to change it if you somehow manage to get it off. So that's a bit of a drawback there. GMRS also gives you a total of 30 channels. Those extra 8 channels, are used for repeater technology, and we'll talk about repeaters a little bit shortly. The first 22 channels are shared with FRS, as we mentioned earlier. Obviously, with the extra power, you're going to have extended range compared to using handheld FRS radio. Some FRS radios are actually as little as a half a watt, depending on the brand and model that you get. That can really hamper the distance that you're talking. Let's see. As we mentioned, repeaters, they're basically another radio in the GMRS service. As we mentioned earlier, folks like Mike have a couple spread out at high points throughout the area to help basically be used as a radio relay to retransmit your signal for you. One of the big advantages I like to GMRS is your battery life is going to be restricted to whatever your power source is, right? So if you have a mobile radio, you're in your truck, you're in your car, your battery life is going to be restricted to whatever your vehicle can generate for you, which is potentially unlimited. With FRS radios, you're really going to have limited battery life because you don't have a mobile radio. You're going to be restricted to however many batteries that you can carry with you as you go through the day. On the price side, radios in the GMRS realm can go anywhere from $25 up to $1,000 or more. And as you start to get into the more expensive radios, you start getting into some of the more high-end functionality and features that are built into the radio. Most of the FRS radios, you can sometimes buy one at a time. It's not uncommon to see radios sold as bundles or 3-packs, but they'll average anywhere between $10 to $50 a piece, depending on the model that you get. Let's see. As I mentioned earlier, while licensing seems like it might be a drawback, what you get for the license is actually a huge benefit. I think the cost of a penny a day is significantly outweighed with the benefits. As we mentioned earlier, having more bandwidth is going to give you superior audio quality. The 50 watts of power can be a dramatic range extender. In the DC metro area, we have some repeaters that were made available to us that will give us 45, 50 mile radius. You can legitimately be 80, 90 miles away from another station and be able to talk to them through the repeaters. So that's a huge benefit. That's something that many of us use almost every day around here. Again, with the detachable antennas, and our friend Mike brought a nice little display here for us to take a look at. There's quite an assortment of antennas available. They have all different benefits with regards to performance, and you're going to be able to pick an antenna that's going to be right for your application, and we'll talk about the differences between some of these antennas in a little bit. Let's see. Yes, installation. So one of the reasons why people are moving away from CB radio, and I hear this a lot, people install a radio in their vehicle and they might only get a mile of use out of it. Sometimes it's even less than that. They get very, very frustrated and they don't understand why it's not working, especially when they hear somebody like me who says, I don't know what you're talking about. I talk anywhere from 14 to 500 miles. CB is fine. And the reason for that is because when you're working with CB radio, these antennas for UHF are fairly small compared to CB. CB radios in a part of the radio spectrum called HF, and the frequency that it's at, a proper sized antenna can be as tall as 104 or 108 inches. Nobody wants to put an antenna that big on their vehicle, right? So you see people getting these little stubby antennas, 3-foot, 4-foot fire stick antennas, whatever the case may be. And they work okay, right? But you're really missing a huge portion of the antenna. They just kind of cheat to trick the radio into being happy, but it's not really a proper antenna. And something else that a lot of installers even get wrong, mobile installers, professional installers don't understand that there's a specific way the antenna needs to be installed. Your vehicle is actually part of the antenna system. So if the antenna is not installed correctly and it's not maintained through the life of the radio, you're going to get absolutely terrible performance with it. Well, GMRS radios are in the UHF spectrum, as we mentioned earlier. They are far, far less susceptible to installation issues and maintenance issues. In some cases, you'd literally have to try to do a bad job to get it to not work correctly. So the fact that it's easier to install and less maintenance is a huge benefit over other services. Let's see. As I mentioned earlier, huge variety of radios. You have everything from high-end bells and whistles and all the features that you could possibly want, or if you're looking for just a really basic radio that works out of the box and you don't have to do anything but turn it on and use it, they're out there. So whatever suits your personality and your need, you can find a radio that's going to cover it for you. So as far as communications types, the first one we're going to discuss is referred to as simplex. Simplex is just two radios talking directly to each other. There's no intermediate resource such as a repeater. The range in frequency goes from about 462 megahertz to 467 megahertz, and they jump around a little bit, and part of that has to do with how the GMRS service has evolved over the years. For the most part, if you're getting a channelized radio, the frequency that it's on is not really going to be relevant for you. But some of the more expensive radios actually have a frequency display, and you'll be able to see the frequency displayed on the radio, so you might see it jump around quite a bit. Now, the UHF frequency propagation is what we refer to as a line of sight service. And again, GMRS is in UHF. So when we talk about line of sight, it's very similar to what the human eye works like. Basically, as far as you can see to the horizon line, radio line of sight is about 15% further. So if you're using a handheld radio or you have a mobile radio with an antenna on your vehicle, your visual line of sight's about 2.7 miles, 2.8 miles. The radio horizon is going to be about 3.2 miles. So the clearest, most direct communications that you would have in that example is going to be 3.2 miles, right? If you go up onto a mountaintop, the visual horizon goes out to 87 miles at 5,000 feet. The radio horizon is going to be 100 miles. So at 5,000 feet, you'd be able to talk in, basically 100 miles in almost any direction, as long as there's not another mountain blocking your view. This becomes important when you're in the woods, if you're in the city. Things like buildings, trees, leaves, they all impact how well the radio waves travel through space, right? So that's something else that you're going to want to keep in mind. Now, it is possible to talk past the RF line of sight, but the further past the RF line of sight you get, the weaker and weaker the signal becomes. And the communications isn't normally considered reliable because you're basically, as a person receiving the signal, you're basically relying on RF energy kind of scattering around the atmosphere, and you're going to be picking up just a small percentage of what you would normally get if you were actually line of sight. Simplex communications is considered the least complex method of radio communications. Again, there's no technology between you and the other person that you're talking to, so it's going to be the most reliable in many cases. Let's see. So here we have just a quick visual on what you would expect in an obstructed view versus a clear view. If you are literally in clear view of the other people that you want to talk to, you're not going to have any problems. And as depicted here, we got some trees and hills blocking the line of sight. So if you were trying to talk to someone that's on the blind side of a hill, or you got to go through some dense woods, they're not going to be able to hear you. Let's see. So most of Northern Virginia, most of Central Virginia, Hampton Roads, Chesapeake Bay, the average terrain transitions around 150, 200 feet. There's some exceptions where there's some rapid drops and rises in elevation, but that's the average for this area. Handheld radios, again, had tendency to have the least range. And it's very important to understand that regardless of what the advertisement says on the package, you'll see some handheld radios will say, oh, it works 32 miles. They're talking about absolute ideal conditions. Again, you're up on that 5,000 foot hilltop. Sure, you'll be able to talk 32 miles if you have a handheld radio, but when you get into the city, really best case scenario city and woods, you're talking 5 to 7 miles like absolute best case scenario, maximum range, you can really expect your average to be that 3 miles, 3.2 miles that I mentioned earlier. And it can be as little as a few hundred yards when we're out in the woods and, you know, either we're hiking or we're off-roading. You get around the blind side of a hill or down in a ravine and you're going to lose connectivity with the person that you want to talk to, even if they're only a few hundred yards away. And again, that's going to be because even in the GMRS world, the handhelds, the antennas are not very efficient. They're still going to be low power. I think the highest power one I've seen is about 8 watts. And again, you're close to the ground, so your line of sight's going to be obstructed. Okay. 50-watt radios, again, going to be a significant improvement over the handhelds, but your range is still going to depend on terrain. Now, with most mobile radios, because you're able to run a little bit more power and the antennas tend to be a little bit higher, most people mount them on the top of their vehicle. Best case scenario, you're going to be looking about 15 miles of range maximum in this area. Of course, as you go up in elevation, that can change. Typical at ground level is going to be between 5 to 7 miles. And again, that's because with the antenna being up a little bit higher on your vehicle, the RF line of sight is going to improve a little bit. You can have as little as a mile, possibly less, depending on the obstructions. As I mentioned earlier, the extra power does help with the RF horizon and extending past it, but it's definitely not guaranteed. I wouldn't count on it. All right, so now I am unaware of any companies that are currently making base stations for GMRS. Everything I've seen is either mobile or handheld. And people do buy power supplies and mobile radios, and they'll use those for a base station at the house. They'll go ahead and put an antenna up on the roof or possibly in a short mast in their backyard. And most of the people that I know that have done a home installation, their antennas are going to be anywhere between 35 feet and higher. They're going to mount them on the roof of the house, or, you know, as I mentioned, if you get like a 35, 40 foot mast. And that's going to push your maximum range out quite a bit. Again, if you're in one of the low spots in town, you're going to be looking about 20, 25 miles maximum range. But for most homes at 35 feet, realistically, you can expect 8.5 miles out to about 10 miles. And of course, the higher the antenna goes, the more you can extend that range. If you had a 150 or 200 foot antenna tower, then, you know, obviously you're going to get quite a bit more out of it. Things like high performance antennas are significantly improved for base stations. There's quite a few different brands that are out there that they're, you know, very high gain commercial quality. So as you spend money on better antennas, you can also increase your ability to hear, which is just as important as your ability to transmit. Oh, cable selection. Definitely want to mention that. Not all cables are made the same. There's different cable technology that's going to perform better in the higher frequency stuff, like what we're doing for UHF and GMRS radio. If you're going to set up a home base station, I definitely recommend doing some research on what the proper cables are. Most folks are using either LMR 400, which is one type of cable that's going to be considered one of the better. And then there's like some really extravagant cable that's made where we call it hardline, and it's a flexible metal outer shielding, and most of them have either heavy foam or air gap insulation inside, and there's just your center lead going up the middle. Hardline's extremely expensive compared to LMR 400, so if you're only running about 100 feet or so, the LMR 400 would probably be okay, but that's really kind of the threshold. Once you start pushing past 100 feet, I'd recommend spending the extra money on the hardline for the house. Let's see. Okay, so we mentioned repeaters earlier. So part of the reason why repeaters work so well is because most of the time the repeater owner is putting them up on a high spot. One of Mike's more popular repeaters is on Bull Run Mountain, not too far from Gainesville Haymarket area. Mike, what are we at, 800 feet?
The repeater is 800 feet above the surrounding terrain. The tower is another 100 feet on top of that. So the antenna is basically 900 feet above everybody down on the ground there. So your line of sight into the repeater and your line of sight transmission out of the repeater is dramatically different than being at that ground level 900 feet below.
Yep, yep.
And it's still easier than driving up to the top of Bull Run Mountain every time you want to talk. But the radio waves do it instantaneously.
Yep, yep. Awesome, thank you. So, yeah, as we show in the picture here, you know, with our original simplex communication diagram, obviously the hills and trees were blocking the person at the bottom of the picture with the handheld radio. With the repeater being up on a high spot, it can see everything while you can't necessarily see anything in your location. So when we transmit to a repeater, we're transmitting on a frequency that's not available to FRS. It's only for GMRS. And there's essentially two radios that make up a repeater system. One of them is a dedicated receiver, the other is a dedicated transmitter. And what happens is the receiver hears your signal and it hands it off to the transmitter, and the transmitter will retransmit your signal on one of the top 8 GMRS channels from 15 to 22. So people who are using FRS radios will be able to hear your signal, as well as other people who are on GMRS. So you may actually hear somebody really well and try and talk to them, and they may not respond to you. There's a really good possibility if that happens, it's because they're talking on a transmitter, or excuse me, on a repeater, and you're trying to talk to them directly, and even though you can hear them because of the repeater, they may not necessarily be able to hear you. Let's see. Something else that's nice about that is all the GMRS radios automatically change channel for you. So when you transmit, when you key up the mic button, it automatically goes to the proper transmit frequency, and when you let the mic button go, it automatically comes back to the receive frequency. Let's see. Looks like we covered quite a bit of this already, with most repeaters being in a high elevation. This is actually something that we should talk about. A lot of repeaters, so all repeaters use what they call a channel pair, and typically the repeater input is 5 megahertz higher than the receive frequency or the simplex frequency that you're operating on. And that's been somewhat standardized through the industry, not just for GMRS, but for commercial radio, amateur radio. It's just common to go plus 5 megahertz. So when repeater owners are putting machines up, they'll follow this general rule of thumb for you. So if you do have a radio where you can customize your own transmit and receive values, that's an important thing to know. Make sure you put the correct frequencies in. That'll be plus 5 for everything that you do. And using one of the channels as an example, we're looking at the channel pair for 19. The simplex frequency is 462.650, which is the same frequency that you would also listen to the repeater on. When you go to transmit, it'll bump up to 467.65 megahertz. Let's see. Repeaters are only allowed to operate on the channel pairs from 15 to 22 as well. Let's see. Okay, so some radios, not all radios are made the same, obviously. When you are talking on simplex, if you have a channelized radio, most of your radios will just display the channel number. It'll say, you know, CH15, and you won't see anything else. That'll typically be what you see when you're on a simplex frequency. When you switch over to a repeater frequency, which is usually just, you know, higher scrolling up in the channel selection, with a channelized radio, you'll either see a plus symbol show up next to the channel option, or sometimes you'll see the letter R in lowercase either before or after the channel selection. to let you know that you're on a repeater pair. The more advanced radios with the frequency displayed and giving you a little bit more bells and whistles, normally they will put a plus symbol to let you know that you are on a repeater pair. And one of the most common issues I see with people not being able to talk to one another while they're out and about is some people will be on a simplex channel trying to talk to somebody on a repeater, or somebody's on a repeater channel trying to talk to somebody on simplex, and because everything's not married up, you just can't hear one another. So that's something to keep an eye out on. You know I'm talking to you. All right. As I mentioned earlier, all of the GMRS channels 1 through 22, they use the exact same frequencies as FRS. Voice communications is 100% compatible. And as I mentioned, repeater use can be a little bit confusing because FRS radios and simplex GMRS radios will be able to hear repeaters. Let's see. Again, we mentioned this earlier, you can mix and match ownership. You can have GMRS and FRS radios. Again, you don't need to ID when you're using an FRS radio. You only need to identify yourself when you're using a GMRS radio. Let's see. All right. So yeah, we covered quite a bit of that. All right, squelch techniques. So this is another one that that I wind up having to help people with a lot. There's a couple of different ways. Well, I guess probably we should start with explaining what squelch is. It's defined as the process of removing unwanted background noise, right? So if you had no squelch on whatsoever, you just hear complete static while the radio is not in use. And it can get kind of annoying. So there's quite a few different squelch techniques that you can use. Some of them you can use joined together. The most common type of squelch is what they refer to as a user squelch or a carrier squelch. And it's typically just something where you're changing the threshold that the radio uses to allow noise to come out of the speaker. It doesn't impact how well the radio can receive or not, just how strong the signal has to be before it actually lets audio come through. So some of the other squelching techniques that are very common are going to be tone squelch and digital squelch. We'll talk about those a little bit more. Let's see. Let me just kind of read through this real quick and make sure I'm not moving too far ahead. Okay, so the tone squelch and the digital squelch methods, on the more expensive radios, they'll actually show you what the digital tone is, or what the digital code is that you're actually using to encode your signal. If you're using a tone, it'll show you what tone frequency you're using. But some of the less expensive radios, and unfortunately Midland, which is a great company, they have a tendency to do this themselves. Instead of actually showing you what your DCS code is or what your tone squelch is, they just assign a random number from like 1 to 43 or 1 to 54 or whatever to indicate which one you've selected, and you actually have to have your owner's manual handy, go find the cross-reference chart and figure out where you are on the dial and tune it to where you want it to be in order to talk. And what gets confusing is some of these manufacturers will they'll refer to these digital code squelches or tone squelches as privacy codes or sub-channels. And those two terminology can be very confusing to some people. There is no secrecy, there is no privacy. So if you have a radio that advertises a private line, it's not that nobody can hear you, it's that you can't hear anybody else. Our friend Randy said it the best. Think of it like going to a hotel and hanging a do not disturb sign on the door. It's not that you can't hear what's going on in the hallway. It's that, you know, nobody's going to come in and try and change your sheets while you're taking a shower, right? So the reason why they put these different types of squelching technology out there is so multiple groups of people can share channels without necessarily interfering with one another. When you use a tone squelch or a digital squelch code, only the people that are in your group and have the same squelch method enabled, those are the only people that you're going to hear. Those would be the only people that hear you if they're running a tone squelch, right? So basically you can have conversations in between conversations, really. And as far as the sub-channels go, again, very misleading. There is no sub-channels. There are only 22, I can assure you. The sub-channels are just them describing what their tone squelches are or their digital squelches are. You can use carrier squelch and tone squelch or digital squelch together. You can even mix tone squelch and digital squelch and carrier squelch together in some of the more advanced radios. And that'll be something that I actually plan on talking about in another presentation. We're going to also try to have an advanced presentation for you to cover some of the more advanced technologies. But as I mentioned, you're having a conversation between the conversation, and that's important to keep in mind when you actually want to go to talk. Almost all radios have a monitor button on it. You can press the monitor button and you'll just start to hear static. It opens up the receiver for you. We try not to cause interference with other people while we're out there, and we have such little radio space to actually use in GMRS. So I always recommend that you listen before you transmit to make sure that you're not interfering with anybody. Just go ahead and mash that monitor button for a second or two to make sure that you're not interfering with someone else's conversation. Let's see. All right, we'll talk about programming your radio. There are many radios that you can buy that will allow you to do custom programming instead of having to adjust menu items through the front of the radio. And there's some significant benefits to having software for programming your radio. It saves a lot of time. You can do everything on the computer. You can even have multiple configurations that you can save on your computer, and you can flash the radio to different configuration settings as you want to possibly move to different areas and access different repeaters and things along those lines. One of the more common programs that are out there is a program called Chirp. Has anybody used Chirp before? Okay, cool. So Chirp is kind of like it's almost a universal software. It doesn't work with every radio, but it works with quite a few radios. And it's a free software application. All you got to do is download it. They do ask for donations, but it's not mandatory. And for radio systems that aren't compatible with Chirp, there's another company that many manufacturers rely on to build their software for them, called RT Systems. And when you buy the software from either the radio manufacturer or if you get it from RT Systems, not only do you get the software itself to do the programming, but a lot of times it requires a custom cable to go between your USB port and the radio, so you'll get the cable that comes along with it. Obviously, with Chirp being a free application, if you need a cable, you're still on the hook to buy the cable. And the cable can be as much as what the software and cable bundle would be from some of these manufacturers, so it's not necessarily cost effective to try and use Chirp and just go buy the cable. One of the drawbacks from using a company like RT Systems is usually their software is only good for one radio, versus Chirp you can program many different types of radios with it. So if you have the cables that you need, you may be able to save a few dollars using Chirp. Oh, something else that's actually kind of neat about the new software that comes out, if you have a radio that uses an SD card, a lot of the radios can actually program from the SD card, which would eliminate the actual need for a programming cable. So when you do set up your radio through the software interface, you can just save it to SD on your computer, And if you got a mobile radio that you want to program like I do, you just go out to your vehicle, you plug it in and load it from memory. It's pretty quick and easy to do. Again, talking about, you know, brand specific, one of the more elaborate programming interfaces is an application called CPS that's used for Motorola radios. And Midland has their software called Midland AG, which is used for their micro mobile series. And that's going to be one of your more common over-the-counter mobile radios that you'll see. So here on the screen, I actually have a quick visual presentation of what some of the more common applications look like. As you look at the top of the screen here, the first image is actually from the programming software for a Midland MXT 500 from the Micro Mobile series. You can see that it has your receive frequency, transmit frequency. You can set up custom channel names, and it shows you step and spacing, which 99% of the time, unless you're an advanced user, just leave those at their default values. It gives you an opportunity to program into memory your power level, as well as any tone codes that you want to use, or digital code squelching or what have you. The next screen down is, let me point this out also. If you're using simplex, you'll see that here both the receive and transmit frequency are the same. So that's going to be an indicator that you've programmed your machine for a simplex frequency. If you're set up for a repeater frequency while you're looking at your programming software, you might see that your receive frequency is at 462, but your transmit frequency would be at 467. So that's something that you'll want to watch for while you're putting your programming together. And then the next application that we have down below here, this is a screen grab from Chirp. Again, very popular application. Now, Chirp is a little bit different as far as it only shows you one frequency, and these are actually your receive frequencies, and you can go through and set up your custom names. And I put some tone examples in here. So if let's say we wanted to do a tone, talking about our custom squelching earlier, right? If we put a tone 85 in here, when we use just tone, we're only transmitting a tone, but we're not using a tone to receive anything. So anybody using any tone or no tone at all, you'll still be able to communicate with them. But if you were trying to hit a repeater, and that repeater might be listening for a tone, in this case it would be 88.5, in order for the repeater's receiver to open up, you can still activate the repeater, but you can still hear everybody who's on simplex, or maybe people who are using another repeater on the same frequency pair that's nearby. And then in the next one down, we have tone squelch. So that's actually both going to transmit your tone, and it's going to require that tone to open your squelch. And you'll notice that in the software, the Chirp software, they have different columns for tone versus tone squelch, and same thing with DCS. The reason for that is to help simplify it for the end user, just to make it less confusing for you as you go through. And you normally, unless you're doing some advanced programming and you've got some experience, you can pretty much ignore the polarity. The point behind the polarity is you in theory can reverse the way the digital code's transmitted and received. And then of course, as we get into more advanced squelching technologies, as I mentioned earlier, you can mix different types of squelching. Now, something that's important here, normally this is a big no-no, but I did it for the sake of presentation and I was being lazy, so I apologize. You'll see on this channel here, we're set up for cross. Something that's kind of important, we see this section here, it says duplex, and we have a plus symbol, and then we have an offset of 5. That's what we were talking about earlier, about how the repeater input's always going to be 5 megahertz up. So in this case, we're saying that we're going to go up 5 megahertz. If you're an amateur radio operator, you'll be aware that in some cases you can go down 5 megahertz as well. And because Chirp is compatible with multiple radios, not just GMRS radios, that's why you'll see the option to do both a plus or a minus. And then we have, hello. Are you mad at me? I think it's mad at me. Here we go. All right. And again, as we move up in complexity of radios, you're also going to have complexity of tuning as well. This is just a quick screen grab that I got from my Motorola programming software, the CPS software. There is an insane amount of stuff in here that you can mess with. It's really considered a tool that a more experienced user would want to use. Usually we have more experienced operators that would buy the Motorola radios to begin with as well. And we'll talk a little bit about the Motorola radios and other options as we move forward. But I mostly just wanted you to get an idea about how complex some of the software could get. All right, so types of radios that you can buy. This is actually a hot topic with a lot of different people. Everybody's always arguing about what the best radio is to buy, right? Me personally, I think you should have one of all of them, right? just get it out of the way, because it's going to happen eventually. You know, so as we mentioned, we got the handheld radios. Most of the Midland radios don't have repeater capability, even though they're a GMRS radio, but they do have more power. If you're not using a repeater, you're not someplace where repeaters exist, then you know you're going for hikes with your family, that might be a great radio to use, right? It's going to depend on your case use. We also have a picture of an Ocean KG1000 up in the top right. That radio is a mobile radio, high power, 50 watt. It's got a detachable faceplate on it. So if you want, you can actually mount the base of the radio someplace hidden in the interior and just install the faceplate somewhere, and it'll give you some pretty significant flexibility with regards to your installation. Something else I want you to notice here too is, using this radio as an example, this actually has 2 transmitters and 2 receivers in it, and they have the display split between the two. So on this transmit receive side, it's on GMRS 22, and on this side it's on repeater 15. So you can actually monitor multiple frequencies at the same time, and you can easily switch between bands by pressing the band button. The other radio down here in the bottom right corner, that's a Midland Micro Mobile series as well. The one in that picture is a model MXT 575. It's a 50 watt radio, and again, it's very much like the Ocean, with the transceiver itself being able to be hidden somewhere in the interior, take up less room, and instead of having a remote faceplate and a microphone, literally all the controls and a speaker are built into the microphone. All of these mobile radios have the option of installing an external speaker as well, so if the microphone speaker isn't sufficient for you, the 3 watt audio output jack on the back of the radio is actually going to be pretty loud. I know 3 watts doesn't sound like a lot, but it's fairly significant. I can hear my 3 watt speaker in that Jeep with the roof and doors off while I'm doing 70. And then we talked about legacy radios as well, right? We have a land mobile radio here that's made by Motorola. And there's quite a few of these radios that were put together for business use that have been grandfathered into the service, for lack of a better explanation. And you can use these radios. Most of these radios are capable of exceeding the maximum transmit power. Most of these radios are capable of transmitting on a wide variety of frequencies that we're not necessarily licensed for in GMRS. But these radios are bulletproof. You can leave them on 24 hours a day, 7 days a week for the next 10 years, and nothing's going to happen to it except for transmit when you press the button. And again, they're usually feature rich. As you saw with the programming software, there's quite a bit of things that you can customize in it. And for us to make these radios compliant, if you're not an advanced user and you want to use one of these radios, get together with somebody like myself or Mike or one of the other people that you'll usually hear on the repeaters, maybe Jack. We all have experience with these. You actually have to program the radio to be compliant with GMRS so you won't get in trouble. And while we're talking about this, I also want to mention the Baofeng UV5R. Man, so many people buy that radio thinking it's a GMRS radio, and it's not. There are a ton of amateur radios out there, and that's what the UV5R is. It's an amateur radio, and it can transmit on MRS and GMRS and amateur radio. Oh, and did I mention, depending on the one you get, you can also talk to air traffic control and pilots at 30,000 feet, and like you can get in all kinds of trouble. So be sure that you're buying a GMRS compliant radio. You don't want to cause harmful interference with another service, especially air traffic, fire, police, whatever. That'll get you in a lot of trouble. And myself and some friends of mine that are in the hobby of radio, we've been paying attention to what the FCC's been doing. And for 12 years, there was nobody, I mean, not one single citation from the FCC for using a non-brand specific radio. It just hadn't happened until a few months ago. And they've done more enforcement in the last few months than they have in the last decade plus. And they are hitting people with huge fines, $14,000, $35,000, $36,000, because they're using non-type compliant radios, causing harmful interference, doing things that they shouldn't be doing. So if you're in doubt about the radio, if there's any question at all about whether the radio that you want to buy is actually authorized for GMRS, just reach out to us. We're available on Facebook, we're on the radio. Just let us know. We'll be happy to talk to you about it. So let's talk about some of the key differences between the different radio types. One of the things that I look for in a radio is going to be how well can I hear, because if I can transmit and everybody can hear me, it doesn't do any good if I can't hear them. So one of the better quality receivers are going to be software defined radios, SDRs. The downside to SDRs are they're extremely expensive. I've seen some that are $7,000. But they're the best performer. They come in the smallest package. You can buy an SDR radio that's almost the size of a matchbook and just stuff it in your pocket. The former champion of receivers was a super heterodyne receiver. They're very robust, very, very sensitive. They're not synthesized, so they're tunable. They're significantly cheaper than an SDR, but they are still a little bit more expensive. We'll talk about the direct conversion in a minute, but if you were to buy a radio that has a direct conversion receiver in it, you'll see that some manufacturers will have another model up from it that has a super heterodyne receiver, and there can be anywhere between $50 and $100 difference between those two radios. And if you're talking about a $200 handheld versus a $100 handheld, that can be a deal breaker for some people. So talking about the direct conversion, otherwise called homodyne, they're the least expensive, and they just don't hear as well as the SDR, the super heterodyne. That doesn't mean they're terrible and not usable. They're still reasonable performance, but I have two different radios in my Jeep, and one of them's got a direct conversion receiver and the other one's got a super heterodyne receiver. And I've lost count of the amount of times that my super heterodyne can hear one of the repeaters or somebody talking simplex, and I cannot hear the conversation with my direct conversion. So just something to think about as far as selection of a radio. All right, so we'll talk about the licensing process a little bit. As you're all aware, a license is required. You can get a 10-year license for $35. You can share it with your entire family. Again, just reiterating, you have to ID every 15 minutes and at the end of a conversation. There's a misunderstanding about when you need to ID versus when you don't. A lot of people think you have to ID when you start talking. You do not. At the very beginning of the conversation, you don't have to identify yourself. You're not obligated to ID yourself until you hit the 15-minute period or you're done talking. Now, there's a bunch of people named Mark on the radio. A couple of them are in this room right now. So if you get on the radio and 1,500 people can hear you, there's a good chance there's more than one Mark out there. So if you go, hey, Mark, you got your radio on? You're going to get like 4 or 5 people try to answer you. So it's become kind of a common habit for people to use their call sign at the beginning of a conversation to identify themselves, because only you, in theory, have your ID. If it's not you personally, it's going to be your wife, your son, your daughter, whatever the case may be. So when you hear people doing it, understand that it's not an obligation. Something else to be aware of is at the end of the conversation, it doesn't have to be the very last thing you say. It just needs to be spoken, or you can use CW if you want to get fancy with it. But it's just going to be sometime at the end of the conversation where it's evident or obvious that you're closing the conversation out. I'll hear a lot of people ID themselves and saying that they're going to go clear, and then somebody will come back and say something to them, and they'll give a quick 10-second blurb, and then they'll drop their ID again, and then another person might pop up and say something else, and then they'll say a third thing and drop their ID again, and now all of a sudden they've used their ID like 4 or 5 times in 30 seconds, completely unneeded. As long as it's at the end of the conversation, doesn't need to be the last thing that you say. All right, so now we had talked about this earlier, trying to figure out where to go on the FCC website. So getting a license, for those of you who don't already have one, it can be a little tricky. In order to get a license, in order to apply for a license, first you have to have an FCC registration number, or what's referred to as an FRN. And to get an FRN, you're going to go to the FCC's website. You're going to go to apps.fcc.gov/cores, CORES. And you're going to see on the page there's going to be a place where it says need a username with a question mark. Just go ahead and click on that registration button. The FRN is completely free. They're just trying to identify who you are. Now, once you have an FRN, you're going to use your number and your password to then log into their wireless licensing application to actually request a GMRS license. Now, this presentation is going to be available on YouTube. I'm going to also share it on Facebook. If you want to make a note of it while you're here, that's great, but don't feel like you have to write it down. I will make it available. But we're going to go to their Universal License Manager, and we're going to log in with that FRN username and password that you created. Now, once you actually get in the website, after you've logged in, this is just a snippet of the top left corner of the web page, and you're going to want to click on Apply for a New License, right? And as you start the process, one of the very first things it's going to do is ask you what type of license you want to apply for. And we're going to apply for general mobile radio, and it identifies it at the very beginning with ZA, Zulu Alpha. And you're going to want to pick that from the drop-down menu and then just continue through the registration process. The rest of it is very, very self-explanatory. And if anybody needs help with it, just let me know. I'd be happy to help anybody with it. Thank you, everybody. I appreciate it. Thank you.